physical geographer. My area of specialty is geomorphology, which is the study of landscapes and the processes that form those landscapes. In particular, I'm a fluvial geomorphologist, so I study how rivers and river processes shape the landscape. So I'm interested in both the flow in rivers and how that flow then shapes the landscape. I'm a fairly new professor, so my research is still kind of rooted with my dissertation. But from that, I study rivers, and I focus mainly on river confluences or river junctions, so where two rivers meet. In particular, I look at a very specific type of river confluence configuration or planform. In the past, most confluence research has focused on two types of configurations, both involving straight channels that meet at angular configurations. So typically in the past we've had what we call symmetrical or Y-shaped planforms, where two tributaries are coming together and actually kind of form a Y, and then the main channel extends below that. And then the other type is an asymmetrical confluence, where we have a lateral tributary joining the main stem of a river. That's all fine and good if we have nice straight channels, but in nature, if you tend to look at a map or an aerial photograph, you'll see, especially in the Midwest, in this region, most of our rivers, if they have not been channelized or altered by man, tend to be meandering, they're bending, they're not nice straight channels. So it stands to reason that kind of this conceptual model of confluences that we developed based on straight channels might not be appropriate in natural settings, because our rivers tend to be bending over their course. The basis of my dissertation was to pick a few sites around central and southern Illinois on the Wabash River drainage system at confluences, 3 different confluences at different scales, and try to examine what we call a confluent meander bend. This is the type of planform. How they might be similar to other confluences, straight confluences that we've looked at in the past, and how they might deviate from typical meander bend dynamics. So that's where my dissertation was focused, just based on the dynamics of this, based on the hydrodynamics, so how flow is moving through this type of junction. And as you can imagine, when you have two flows meeting, it's a highly complex environment. And you add some curvature to that now, instead of just straight channels, you get a very complex hydrodynamic environment and morphodynamics. So you get some very unique flow features and some very unique bed morphology features. I was just recently received a grant where I hope to take a step back actually and do kind of a simple inventory just using aerial photographs and GIS, Geographic Information Systems, to inventory confluences in a good chunk of the Wabash River drainage basin. So we plan to actually count and evaluate every single confluence that we can see on an aerial photograph of the drainage basin, and attempt to categorize it. We're going to attempt to quantify the characteristics of these confluences. So what type of curvature is there, channel width, typical stuff like this. And surprisingly, this really has not been done before. Certainly people have conducted maybe smaller inventories in the past, but nobody has really conducted a very rigorous inventory where we attempt to understand are confluent meander bends frequent in nature, like we suspect they probably are, or do we see kind of straight channel confluences, which probably doesn't make a whole lot of sense, since we know naturally that most of our streams are meandering. One of my sites was the Ohio, the junction of the Ohio River with the junction of the Wabash River and the Ohio River in southern Illinois. This is kind of an interesting site because upstream, just upstream of this confluence, we had rapid channel change occur on the Wabash River over a short period of time. essentially there was a meander bend that was occurring before the junction on the Wabash River, and we had a cutoff occur. So we had actually a flood condition in June of 2008, and that flood kind of cut away, it cut a new channel, and so essentially we're creating an oxbow lake now where the meander bend used to be, and so we've totally changed the gradients of the lower Wabash River. So that's interesting in and of itself, but I'm curious how that's going to impact the confluence, which is about a kilometer or two downstream of this site. As a result of this, you can imagine we're carving a new channel, so lots of sediment is being fed into this confluence. And the Ohio River is a major, it carries lots of barge traffic. It's a commercial waterway. So after this has occurred in June 2008 and in subsequent events, flood events, lots of sediment has been accumulating in the channel of the Ohio, and it's clogging up the shipping lane. So they actually have to halt barge traffic, and the Corps has to go through, the Army Corps of Engineers has to go through and dredge the channel. So there's kind of a practical application to this. I would be interested in seeing then how this cutoff upstream that occurred on the Wabash River and is dumping all this sediment into the Ohio, how is that going to change the dynamics of the confluence over time? Are we going to see rapid channel change in the confluence? Is the confluence going to start to rearrange itself to adjust to this new channel change upstream? I think that would be an excellent project, and potentially have really practical real-world applications, because it would help potentially the Army Corps of Engineers to alleviate their problems with navigation through this area.